Hello friends, I'm Siddharth before you to explain about my new topic in data structures, that is hashing. So hashing is a concept which is used to store a concept which consists of a hash table and which stores elements in a specific order in a specific calculation. So while coming to our program, I have defined this is a parameters as int t and I have initialized an array. So here I'm using the functions such as void hash insert and void hash delete, void show, that's etc. So here in this hashing, it consists of a hash table which has the table consists of a number of slots, that is of size n. So the element which we want to enter is entered into the hash table on a specific slot with a definite calculation, that is divided by the number divided by the number of total slots. So the remainder obtained, the number of the numerator of a remainder obtained, the data is sent to that remainder of the same slot numeral. So now coming to our program, I'm initializing the function void hash insert, and I'm initializing some parameters, data and etc. So if you want to enter an item, see in data, the data is the element which you want to insert. So int I is equal to data modulus of t, that is it fetches the remainder, in which the I is equal to the remainder, and the data is stored in the remainder numbered slot. So here while loop and while one is initialized in order to specify infinite loop. So if array of the initialized element is equal to -1, so array of I is equal to data, the data is incorporated in the slot, or else I plus plus, that is a slot moves as a slot moves from if the slot is not empty over here, it come to the next slot, so and so. If I is equal to t, then I is equal to 0. So if I is equal to data modulus of t, it means if the remainder, the I is a numeral to which it comes again after once the successive cycle, then we can say that there is no space is available in table. So again now the void hash delete, the same way the data is being entered, the data to be deleted is been entered, and it is the numeral, the remainder has been calculated, and if the array of I is equal to data, means the data which you have entered is occupied, is available in that slot, then item is equal to data, hence it's deleted, or else it searches up for a success after the successive terminals, and then if it gets that it is deleted, or else if I is equal to data mod t, then that you can specify that the data is not found. So here void show, the void show function displays the elements placed in the contained in the void table. So for int I is equal to 0, I is less than t, I plus plus, if I is equal to -1, can continue that it continues display the array elements in the array. So here comes the main function, and now we are initializing this using a switch case. So enter the table size, that is as the size of the hash table, see int t. So for I school, for initializing a for loop, and then we are framing the slots, so int n, and while one which represents infinite loop, see out, enter the choice, and now this the operations of the hashing are being implemented using a switch case. So here the switch is enabled, and case 1 hash insert, case 2 hash delete, case 3 display, case 4 return, etc. So here comes the end of experiment, and we could see its output. So hence we obtain our output. So I am giving a number of 9. I want to insert 67. Again I want to insert. So once we'll display the elements, that is option 3. So here the 0 is a 45, as 45 is divisible by 9, we'll get a remainder 0, and 67 is a 4, as 63 is divisible by 9. The 4 is the remainder, so it's going to the slot number 4. So if I want to delete, so I want to delete 67, hence it is 3267. If I'll want to delete a number which is not contained in the hash table, that is 78, so the entry data not found, hence our code is working. So here comes to the next end of our experiment, and our experiment on hashing is successfully implemented. Thank you.